Hello and welcome to our presentation. It is about our study of the utility of the text classification-based software architecture recovery method RELAX for maintenance. Now for our introduction. Knowing a system's architecture has benefits for maintenance, research, and other purposes. An architecture is often not available, but can be retrieved using architecture recovery methods, algorithms. Concern-oriented architecture recovery clusters source code entities, which are usually files, by concerns, which can be understood as features. Our recovery method, RELAX, which stands for Reliable Architecture Extraction, does this by using text classification, which is an NLP technique. Here we can see an example of the textual output produced by RELAX. The syntax is contain, concern cluster, and canonical name of code entity. As you can see here, the elements of the syntax are mirrored in the text output file, and they are applied to the individual code entities, in this case Java files without the .java suffix. Here we see an example of the graphical output. It shows a directory graph of a system. On the right side is a legend that shows the concerns that were selected for this recovery. No match is used when none of those concerns applies. Lines are connecting directories, Java packages, with their contents, which can be more Java packages or Java source files. Each line is colored for the prevailing concern in the package. The boxes around groups of source code entities stand for packages. Since the utility of RELAX for maintenance had not been studied yet, we became interested in running our own study. We had two study questions. First question, does using RELAX architecture recovery results reduce the time to find the location in the code where maintenance needs to be performed? Second question, what are the perceptions of new maintainers who work with RELAX architecture recovery results? For our study, we had 9 computer science master students with some Java programming experience, which meant at least 1 year of Java programming experience in academic or industrial settings. Each participant committed 8 hours overall, distributed over 4 weeks with 2 hours per week. We had live sessions with our participants, so we had more control over what happened during the experiments. And our survey collected data before the study experiments, such as existing experience, and then impressions and observations after the study experiments. Our study experiments were conducted on the current version of Apache Jackrabbit, which at the time of our experiment was version 2.20. The first task was, you are tasked with making fixes to a file system that interfaces with a database. In order to start your work, you think of adding a few print statements, but where? Task 2, clean up the system after an unreachable former contributor has made modifications to one source file, so it doesn't handle security anymore, but SQL instead. The source file was not renamed. You want to make the system maintainable again and change the name of that file, but where do you look? Our observation has been that for study question 1, the average speedup factor for the first task was 5.4, and for the second task, 7.4. This is the average time of the control group divided by the average time of the experimental group. For our second study question, the results were that we got strong agreement on that the participants can learn the structure of the system from RELAX, that it can support new contributors to a system, that different versions of an architecture are easy to compare using it, that running it in real time, for example, as an IDE plugin would be valuable, and that it can be used as a source to get started on other maintenance tasks. To briefly discuss this and think of the implications, we have seen that the start of the maintenance is sped up by at least a factor of 5.4, that the participants strongly consider relax use helpful for maintenance, and that an IDE plugin should be considered for real-time relax architecture recovery. And we're going to talk about that on our next slide. Here we see part of the GUI that we would have in mind for our hypothetical IDE plugin. On the left would be an overview of the architecture, like we had seen earlier, the directory graph that can be zoomed into. In the example, we're seeing how one source code entity is magnified. It's called SQL joint test. That's the canonical name of a Java source code entity. It would show the file size and logical software line of code size, incoming and outgoing dependencies. And in the smaller text below, it would show that the architecture has some issues that need to be looked at. In the middle, we see a potential layer dependency warning where audio driver depends on GUI when this dependency is undesirable. And on the right side, we see a potential configuration dialog box in which auto recovery of the architecture after each compilation could be configured. We would think that such an IDE plugin would benefit maintainers. Thank you, and this concludes our presentation.